Good afternoon. Good afternoon, my dear student. Today, in this class, we want to discuss about the electrochemical cell or the chemical equilibrium. Basically, we'll not concentrate ourselves in case of the electrochemical cell. We need some the information about the electrochemical cell. Then we'll get lot of information about the electrolysis of the salt and deposition of the metal and etc. So today we will discuss about the electrochemical cell, though it is the topic, but mainly we will discuss about the chemical equilibrium. So here, as we are discussing the chemical equilibrium, we know what do you mean by equilibrium. So as there will be lots of equilibrium is possible, that is mechanical equilibrium, chemical equilibrium, and lots of others thing. But here we only discuss about the chemical equilibrium. Yes, student, here again I am Dr. Biswajit Kain, your chemistry teacher, assistant professor, Department of Chemistry from your college, Dr. Sudhir Chandrasoor Institute of Technology and Sports Complex. So if you look into this picture from your first slide, that the chemical equilibrium. So chemical equilibrium means, if you look into the diagram, that is rate versus time, then the rate of the forward reaction will be decreases, and initially the rate of the reverse reaction will be increases, and after a particular time the rate of the forward reaction and the backward or the reverse rate will be same. So after that point, that is this point, then when it become a single line, then at this stage the rate of the forward reaction and the reverse reaction is set. So ultimately there will be no change of the chemical composition in the reaction. So if you look into this water tank, so there is a input and output. If the rate of input and output are same, then the water layer in the tank will be remain constant. So you will look that there will be no change in the water tank, but ultimately there is a change is happening within the water tank, but it is in the dynamic equilibrium. So before going to the discuss about the chemical equilibrium, I want to say something about the process and others detail. That is, first one thing is the reversible reaction. So reversible reaction means, that is, if you add A plus B and it forms C plus D, so this reaction have another possibility. By combine C and D, it get back to form A plus B. So this type of the reaction is mainly called reversible reaction. So here, if you take a real example, that is nitrogen and hydrogen react with each other and form ammonia, but simultaneously, yes, it is possible ammonia will be broken down and it form nitrogen and hydrogen. Yes, both two things are possible. So in that case, yes, this reaction is in under equilibrium, and the equilibrium sign is represented by this double-headed arrow, opposite double-headed arrow. So what are the conditions for a reversible reaction? So reversible reaction must be is like that is rate of the forward reaction and the backward reaction will be same. But now I want to discuss about the irreversible reaction. So irreversible reaction is the unidirectional. So if it is changes happen, there will be no chance to come back to its initial stage. Like if you add silver nitrate solution in NaCl solution, then it will form silver chloride and sodium nitrate. So silver chloride salt is stable and it will be precipitated. So here it is not possible to come back the reaction, but that is if you react AgCl and NaNO3, then it is not possible to get AgNO3 and NaCl. So this is called the irreversible reaction. That is the burning of the magnesium in presence of the oxygen, it will produce oxide of magnesium. So it is unidirectional, that is forward direction, and it will be occur in the forward direction. Or simply if you consider the burning of fuel, so yeah, in your fuel the carbon is present and it is burned in presence of the oxygen and is converted to the carbon dioxide. So it is unidirectional, but no reaction is basically unidirectional. But if you take or close if you uh, perform the reaction in a closed vessel, then yes, the carbon dioxide again will be broken down and form carbon and oxygen. But in open system, yes, the carbon is reacted with the oxygen and form carbon dioxide. So it is irreversible reaction, that is unidirectional. Now equilibrium. So what is the definition of the equilibrium? If a reaction is said to be in equilibrium when the rate of the forward reaction is equal to the rate of the backward reaction. So I have already told this thing about the reversible reaction. So here the equilibrium position is that when there will be no change of the composition of the reaction or the solution and other things. So ultimately there will be no change in the system. So this is called equilibrium. So if it is the forward and backward rate of the reaction is same, then yes, it is possible there will be no change. So this no change zone or area or this phenomenon is called equilibrium. So there are different type of the equilibrium is possible, that is physical equilibrium, chemical equilibrium and ionic equilibrium. But student, we will mainly discuss about the chemical equilibrium because this is it in your syllabus. If you think about the physical equilibrium, it is very easy and you are well known about this, that is solid to liquid. That is if you consider the ice and water. Now what is chemical equilibrium? So if you go to the point wise, then general characteristics of a physical and chemical equilibrium is or are they are dynamic nature, that the equilibrium will be dynamic. So if you suppose you are taking a iron rod and you are saying that there is no change of the composition, but this is not the equilibrium. But if you consider the nitrogen and hydrogen and the production of the ammonia, so then if in a particular situation, if the rate forward and the backward reaction rate is same, then there will be no change of the composition. So ultimately this is called the equilibrium. At equilibrium, concentration term of each reactant and product become constant. So that's why I was saying about the composition. It should be closed system, because if the ammonia produced and it is eliminated, that is if you perform this in an open system, then the equilibrium is not possible. So chemical equilibrium can be attained from either direction. Yes, obviously, um, both side is important. Here, catalyst cannot alter the chemical equilibrium, but it can enhance or decrease the rate of the reaction, but ultimately it have no role in equilibrium. So if you want to get the details about or make some calculation or higher level, then you have to know some laws, that is law of mass action. So it basically tells us about that the rate of a reaction is directly proportional to the product of the molar concentration of the reactant. That is, the reaction rate, that is forward or backward, will be directly proportional to the molar concentration. Or basically, here I want to say another word, that is active mass of the substance. And the reactants raised to the power of their stoichiometric coefficient. So this will be very clear if you take an example. So here, small a is the coefficient. So if you look into this reaction, then rate of the forward reaction will be like this, that is the concentration of the a to the power small a, that is a is the coefficient, into concentration of the b to the power b. So ultimately Rf equal to Kf, where is the forward rate constant and concentration of A and concentration of the B. So similarly, if you consider the backward reaction, then Rb will be equal to Kb, concentration of the C and concentration of the D. So now if they are same, then Rf will be equal to Rb. So this is the thing. And now Kf by Kb, this is constant or it can be replaced by K. So then it will be concentration of the C into concentration of the D by concentration of the A and concentration of the B. So here this K is the equilibrium constant, and it has very the equilibrium constant have very important terms in concern of the chemical reaction. So there will be a different type of the chemical reaction, that is if it is in the solution, then it will be expressed in the concentration, that is solution or molar concentration. And if it is in the gaseous state, then we consider the partial pressure, that is Kp. So here the Pa is represent the partial pressure, and there will be a relation. Yes, there will be a relation is possible, that is Kp, that is rate constant in the gaseous state is equal to the rate constant of the solution into RT to the power del N. So these are the thing. So if it is if a particular reaction at in equilibrium, then obviously the rate of the forward reaction, rate of the backward reaction are same. But if a reaction is not in equilibrium, then the concentration of the product by concentration of the reactant will be like that. that is QC, which is called reaction quotient in terms of the molar concentration. So if you look here, that is forward direction and backward direction, so then you will see that if Kc is equal to Qc, then obviously it is under equilibrium. But if Kc is higher than Qc, then the reaction tend to move forward in order to attain the equilibrium. So here the forward reaction rate is very high, or basically the equilibrium constant is defined as the Kf by Kb. So as the Kc is high, so obviously the forward reaction rate is high. Or if the Qc is greater than Kc, then the reaction tends to move backward in order to attain equilibrium. So this is a very simple parameter. Now there will be some characteristics of the equilibrium constant. Yes, it is constant for a reaction, and it alters only if the temperature changes, because the equilibrium constant is dependent on the temperature, and it is not affected, I have already told you, it is not affected by adding of catalyst. If the reaction is written in two steps, the equilibrium constant is equal to the product of equilibrium constant value of the two steps. So if the reaction takes place in the two step, then the overall equilibrium constant will be the multiplication of the first step, or equilibrium constant of the first step and the second step. If K value help to predict the extent of the reaction, if K value is greater than 1, that means is more to the forward direction and vice versa. That is, if K is greater than 1, that is the rate is the forward reaction rate is very high, and if it is below 1, then the backward reaction rate is high. So there are lots of parameter which can hamper the, or can change the equilibrium constant value. That is for endothermic reaction and exothermic reaction, it will be reflected. Here the Gibbs free energy will be changed, but this complicated thing are not in your syllabus, so I am not going through this. And here the different equilibrium constant for different type of the reaction. So you just go through it and you will get an idea about this. So there will be a direct relationship by taking an example of formation of the ammonia, where in this slide they try to correlate the relation between Kc and Kp. Here the same thing. So this is very important, but you have not required, but you have please store this thing, that this type of the thing, yes, it is possible, and this type of the mathematical problem is really exist, but it is not in your syllabus. So these all are correlated. I have already told you that the equilibrium constant can be affected by means of different thing, and yes, the equilibrium status can be changed by concentration, by temperature, by pressure, and lots of things. But to know all about this, the Le Chatelier's principle is very important because you have to know Law-Satire principle, and from that you will get an idea about the dependence of the temperature, pressure, and concentration and others, that is catalyst on the reaction and the equilibrium. So in the next class, obviously, we will discuss about the factor affecting equilibria or equilibrium, and that is the discussion of the Law-Satire principle. So student, hope you will enjoy the class, and if you not understand any part of my lecture, please inform me, and yes, I will help you from my best, and from yes, I will always want to stretch my helping hand toward you, so don't hesitate to ask me. So thank you student for your kind attention, and student, in this scenario, in this present situation, take care yourself and in your family. Thank you.